Hello, students, and welcome. Today, we are going to explore a very fundamental question in chemistry. How and why do some elements react to form completely new compounds?
So let's start with a puzzle. If you think about the elements you know, why do they have such different personalities? You see, some are very unreactive, like the helium inside a balloon, but others, like sodium, are very, very reactive. The answer lies in their quest for one thing: stability.
Okay, let's dive into this. In the world of elements, the noble gases are like the calm, stable role models. Every other element wants to be like them, so what makes them so special?
Now have a look at this table. What's really interesting here is the outermost shell of these noble gases. Notice how both neon and argon have 8 electrons in their valence shell. This is very important. You see, this filled shell, this stable octet, is the secret to their non-reactive nature. They are happy and stable, so they don't need to react with anyone. They are complete. But what about the other elements? They are not stable, so they will react to achieve that stable octet. And they do this in 2 different ways, either by giving away electrons or by taking electrons. And here we see the 2 different approaches. Metals, like sodium with its configuration of 2, 8, 1, find it much easier to just lose that one outer electron. But nonmetals, like chlorine with 2, 8, 7, find it much, much easier to gain one electron to complete their shell. Just think about it for a moment. It's really a simple matter of energy. Losing one electron is far, far easier than trying to find and gain 7 more. And this is the key reason why metals always tend to lose electrons.
So the crucial question is, what happens when a metal that wants to give an electron meets a nonmetal that wants to take one? Let's see this process in action with a very common example: table salt or sodium chloride.
Let's try to picture this. The sodium atom has one lonely electron in its outer shell, and the chlorine atom has one empty spot in its outer shell. The electron literally jumps from the sodium atom and goes to the chlorine atom. Now both atoms have achieved that stable configuration. Now by giving away its electron, the sodium atom is no longer neutral. It still has its 11 positive protons, but now it only has 10 negative electrons. This imbalance creates a positive charge. It becomes the sodium cation, which we write as Na+. And in the same way, chlorine, after accepting the electron, has its 17 protons, but now it has 18 electrons, so it becomes the chloride anion with a net negative charge, which we write as Cl-. So now we have a positive ion and a negative ion, and as we all know, opposites attract. This very powerful attraction holds them together tightly to form sodium chloride. This attraction is a strong electrostatic force.
Okay, let's move to another example and see how this idea builds. What if an element needs to give away not 1 but 2 electrons?
Well, magnesium has 2 electrons to give, but a single chlorine atom can only take 1. So the magnesium atom needs to find 2 chlorine atoms to complete the transfer. It gives 1 electron to the first chlorine and the second electron to the other chlorine.
And so the crucial point here is charge balance. The total positive charge, which is +2 from the magnesium, must equal the total negative charge, which is -1 from each of the 2 chlorines. And that is why the formula is MgCl2, with 2 chlorine atoms for every 1 magnesium atom.
This entire process of giving and taking and the powerful attraction that follows has a special name in chemistry. Let's look at what that is. And this definition explains it perfectly. It's not about sharing electrons. It's a complete transfer followed by a powerful attraction. This type of bond is called an ionic bond, and the compounds formed this way are called ionic compounds. So, let's just quickly recap what we've learned today. These are the main points to remember. First, elements react to get a stable electron configuration, just like the noble gases. Second, metals do this by losing electrons to form positive ions, or cations. Third, nonmetals do this by gaining electrons to form negative ions, or anions. And finally, the strong electrostatic force between these opposite ions is what we call the ionic bond. We have seen how these compounds are made, but what are they like? In our next lesson, we will explore their special properties, which are a direct result of this powerful ionic bond. Thank you for your attention.